Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 1 and our main topic is on application of differentiation in a linear approximation, or what we call the small changes. Now we need to understand what we mean by linear approximation. So let me write linear approximation. This simply means that it is a technique, This is a technique used to estimate values, of some functions, close to some known results, So that is what we call linear approximation. For example, I may ask you to use differentiation techniques to approximate the square root of 26, or I can ask you to approximate cosine of 37 degrees, or you approximate the fourth root of 80. All those, when you use your knowledge of calculus, that technique of approximating the values of such kind of functions is what you're calling linear approximation. So you know how to find the equation of a tangent line and normal line at any given point. So that's what you're going to use to derive the formula for linear approximation. So I want us to take note. Take note that the equation of tangent line line at point x0, y0 on the curve y is equals to f of x can be used to approximate the function y of x. Can be used to approximate the function y of x, or y is equals to f of x, close to this point, close to the point x0, y0. Now, how do you find the gradient of a curve at a point? It is simply equal to the gradient of the tangent line to that curve at the same point. So you can write this, that the slope or gradient of y is equals to f of x at point x0, y0 is the same as the slope of tangent line at the same point x0, y0. This simply means that this slope of a curve is dy dx at the same point where x is equals to x0, or the point x0, y0. This is the same as what we are calling y prime at x0. So if you know the gradient of the tangent line at a point. Are you able to find the equation of that tangent line? So now, equation of the tangent line. You know, for you to find the equation of a tangent line, let's say the line is this. And let me draw a proper line, a straight line. Let's say we have this straight line. All you need to know about a line is the point, the known point on that line, x naught, y naught. You also need to know a general point x, y on that line, and you need to know the slope. Slope is equals to y prime at x naught. When you have those three things, you can be able to find the equation that change in y over change in x is equals to the slope. This simply means that y minus y naught over x minus x naught is equals to y prime at x naught. And if you cross multiply, or if you make y the subject, you're going to get y minus y naught, we are cross multiplying, is equals to y prime at x naught times x minus x naught. So therefore, you can now make y the subject. So you can say therefore, from that equation, it means y, remember y is a function of x. Y, a function of x, is equals to y naught plus y prime at x naught times x minus x naught. What I'm calling y naught, take note that the y naught here is the value of y when x is equals to x naught. That's what I mean by y naught. So when I make that substitution, instead of y naught, I'm going to write y of x naught. So this can now be written as y of x. And I told you that also the y here is a function of x. So instead of y, I'll write y of x. It's also very important. So that we are saying y of x is equals to y of x naught plus y prime of x naught times x minus x naught. This is the formula that we are going to be using when we are dealing with problems in linear approximation. This is what you are calling Taylor series expansion of the function y of x about the point x naught, but you truncate up to the first order term, first order Taylor series expansion of that function at point or about the point x is equals to x naught. So that's the formula we are going to be using in linear approximation. Now, let's look at an example. We'll start with the simplest example. So I want us to use linear approximation to estimate the following. So you can write example. Examples, you are asked to use linear approximation to estimate the following. In part A, we need to estimate the square root of 26. How do you apply the knowledge of calculus to be able to work out this problem? This is how you start. You are going to say that let x be equal to 26, so that or simply before we say let x be 26, first of all, let's say let y be equal to the square root of 26 and x is equals to 26, so that y of x, or simply y, is equals to the square root of x. So that y is equal to the square root of x, which you can write as x raised to 1 over 2. Also, let x naught be equal to 25. Why are we choosing 25? This should be a number close to 26 and has exact square root. Exact square root. So that will be our x naught. So now we can be able to find our y naught, now that you know x naught. So you can now say, therefore, our y at x naught, which we are saying y naught, will be the square root of x naught, which is the same as the square root of 25, and that will give us 5. So now we know y x naught. Now we need dy dx. So you again calculate dy dx. Dy dx is equals to, let's differentiate this function. Dy dx, we differentiate this, so that will be 1 over 2 times x raised to negative 1 over 2, which you can write as 1 over 2 root x. So now that we know dy dx, I need to find y prime. Remember, dy dx is the same as y prime of x. So now from here, therefore, it means y prime at x naught is simply equal to 1 over 2 root x naught, which is equals to 1 over 2 root 25. Root 25 is 5, so the answer here is 1 over 10. So now we have everything that we need in our formula. So I'll just go and substitute these values into the formula. So we can just say, hence, y should be equal to y at x naught plus y prime at x naught times x minus x naught, which you can also write as y at x naught, we got 5, plus y prime at x naught, we got 1 over 10, x is 26, minus x naught is 25. So this you can write as 5 plus 1 over 10, which is 5 plus 0.1. And so the result here is 5.1. So it simply means that, therefore, the square root of 26 is approximately equal to 5.1. That is, if you use linear approximation. You see, it is very simple. No need of a calculator, but we are simply applying the techniques of differentiation to be able to approximate values of some functions. Another one, let's see how to work out this. But B, we need to work out 80 raised to 3 over 4. What is the value? So again, as usual, we say let y be equal to 80 raised to 3 over 4, and let x be equal to 80, so that y will be equal to x raised to 3 over 4. So now we know y as a function of x. So now we need to also find x naught. Also, let x naught. What do you think will be our x naught? I need a number that is close to 80 and has exact fourth root. That number can be either less than 80 or greater than 80, as long as it has exact fourth root. The closest number which has exact fourth root and is near 80, that number is 81. Let me explain here that my choice of 81 is that it is a number close to 80 and has exact fourth root. That's why I chose 81. So now that we know x naught, we can now be able to find y at x naught. So you can say that y at x naught, remember, this is y of x. Y at x naught is equals to x naught raised to 3 over 4. That is simply 80. Now x naught is 81, not 80. So I'll write this as 81 raised to 3 over 4, which you can write as 81 raised to 1 over 4. Then the answer you have found, you cube it. When you write 81 raised to 1 over 4, it means the fourth root of 81, which is 3. And this answer, we now need to cube it so that we get 27. That is our y at x naught. What else do we need? We need y prime of x, or what we are calling dy dx. Differentiate this equation. Use power rule. That will give you 3 over 4. X raised to 3 over 4 minus 1 is negative 1 over 4. That is dy dx. Now, I need dy dx at x naught. So you can write y prime at x naught is simply equal to 3 over 4 times x naught raised to negative 1 over 4. And I know x naught, so this is the same as 3 over 4. Our x naught is 81 raised to negative 1 over 4. So that is 3 over 4. This is 4. 3 over 4 times 3 raised to negative 1. You see, I have found the fourth root of 81, which is 3, and it was raised to negative 1. So anything raised to negative 1 is the same as 1 over that number. So like here, it is 1 over 3. 3 over 4 times 1 over 3, and we expect our answer to be 1 over 4. Remember, the laws of indices are very important here. We are not using any calculator. So this is the same as 1 over 4. Very important. What else do we need to find? Already we have y prime at x naught. And now we need to find the value of y. Approximate now the value of y using the linear approximation. So we can just say hence y, if you now need y, is equals to y at x naught plus y prime at x naught times x minus x naught. And y at x naught, we have found it to be 27. Y prime at x naught, we have found 1 over 4. X is 80. X naught is 81. So this will give you 27 minus 1 over 4. That is 27 minus 0.25. And so that will give us 26.75. So we have found that again by linear approximation. So you can now say, therefore, 80 raised to 3 over 4 is approximately equal to 26.75. That is, if you use linear approximation without the aid of your calculator. We look at one more example, how to use linear approximation to estimate, let's say, cosine of 44 degrees. Let's work out with that. We work with cosine of 44 degrees. So in part C, we need to estimate cosine of 44 degrees using linear approximation. So what you do here, the steps are the same. Let y be equal to cosine of 44 degrees and x be equal to 44 degrees, so that y is equals to cosine of x. Y is equals to cos x. Now, we also need to find x naught. So we again say let x naught. Now, you need to ask yourself, which angle is close to 44 degrees, and you know the exact cosine of that angle. And the angle there is 45 degrees, because we know the exact value of cos 45 degrees. So our x naught is 45 degrees, but this must be converted to radian. Let me explain the choice of 45 degrees. An angle close to 44 degrees and has exact cosine, because we are talking of cosine, so we need exact cosine. You know the cosine of 44 degrees? I'll tell you how to find it. Now, when you deal with angles, it is better to convert the angles to radian. Let us convert them to radians. Take note that when dealing with angles, or simply if your function is trigonometric, then it is better to convert the angles to radian. If y is trigonometric, let me write that in a better way. If y is trigonometric, or hyperbolic function, comma, then convert x and x naught to radian. Convert x and x naught to radian. That's what is important here. So let me show you how to convert them to radian. So what is 44 degrees? Remember, we are going to use this identity, or simply this formula, that 180 degrees is the same as pi radian. 180 degrees is the same as pi radian. That is how you're going to convert from degrees to radian. So therefore, what will be our x naught and what will be our x? Let's start with x naught. X naught will now be, if 180 degrees is equal to pi radian, what about 45 degrees? That is 45 pi over 180, and this is the same as pi over 4. What about x? X will now be 44 pi over 180. When you simplify, that is 22 over 90, which is 11 over 45. 11 pi over 45. So that's what we have. Remember, I've divided by 4 in the numerator and also in the denominator. Now the question is, what is cosine of 45 degrees? We said we know the exact fourth root. Here we are not using any calculator. Take note, we need to find y at x naught. Look at our y of x. Let me bracket this. This should be y of x, or simply y is equals to cos x. So once you have converted those to radian, all you need to find is y at x naught and y prime at x naught. So let's find those ones. So we can now say that therefore y at x naught is equals to cosine of x naught, which is cosine of pi over 4. Cosine of pi over 4 is the same as cos 45 degrees. I'm going to draw this triangle to illustrate how to find cos 45 degrees. A right angle triangle. If this is 90, then this must be 45, because I want this side to be equal to this side, and this angle must also be 45. If I say let this be 1, this must also be 1, and when you use Pythagoras theorem, this will be root 2. So from that triangle, cos 45 from this triangle is adjacent, which is 1, over hypotenuse, which is root 2. So which is the same as cos pi over 4. So the answer is 1 over root 2. What else do I need? I need y prime of x. Y prime of x is the same as dy dx, which is equals to, differentiate cosine, you get negative sine x. You get negative sine x. Now from here, we can now find y prime at x naught, which is y prime at x naught. Look at our y prime, that is the same as negative sine x. Let me not write this. This negative sine of x naught, which is negative sine. Our x naught is pi over 4. What is sine pi over 4? Pi over 4 is 45 degrees. Read from the triangle. Sine is opposite over hypotenuse. And that again is 1 over root 2. So it is negative 1 over root 2. What else do we need? We have everything. And so just go back to the formula, substitute those values that you have found. So we are going to say that hence the y that we need is now given by y at x naught plus y prime at x naught times x minus x naught. And we know y at x naught, we got that as 1 over root 2 plus y prime at x naught, we have found negative 1 over root 2 times x. Our x is, in terms of radian, we got 11 pi over 45 minus our x naught, we got pi over 4. So we have that. And now you can be able to simplify this. Simplify this one. So that, let's see, what is 11 over 45 minus 1 over 4? You can now try that. That should give you negative 1 over 180. So when I work out this, I'm going to get 1 over root 2 minus 1 over root 2 times negative 1 over 180 pi. And you see 1 over root 2 is common. You can factor that out. 1 over root 2 into 1 plus pi over 180, which I can write as, of course, pi over 180 plus 1 is the same as 180 plus pi over 180. So this 180 plus pi, 180 plus pi over 180 root 2. That is the approximation for cosine of 44 degrees. Now, this one you can press in the calculator. It's not easy to know the value there. You can write 180 plus shift pi, that is 183.14. Then we are dividing by 180 times root 2. That should give you approximately 0.71945. 0.71945. 0.71945. So you can now say that therefore cosine of 44 degrees is approximately equal to 0.71945. So you see, we have used linear approximation to be able to find that value. And if you have any other problem different from the ones we have looked at, as long as you know how to begin, you know the methodology, then you should be able to find the value when you apply the concept of differentiation. So thank you all for watching this video. Don't forget to subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube page, type Francis Okech or Prof. Francis Okech, and you'll find me right there. Also, comment, share, and like this video. When you meet next time, we look at other applications of differentiation. Bye-bye.